All right, this is part 3, I think, of our review of exponential functions. In this part, it's all about solving exponential equations. Some of them pretty crazy looking exponential equations. So let's get started. Okay, keep your table of powers handy because we're definitely going to need that at some point. Solving these equations is all about coming up with like bases. So, see all these big numbers? I would look for these numbers on your chart if I were you. So, 2,401, is that on your chart anywhere? In the sevens. All right, can you see that 2,401 is 7 to the 4th power? Okay, so coming back to the paper, we will write this as 7 to the 4th power. The 3x, just put it in parentheses. Okay, let's do the same thing with these other two numbers. All right, what about 16,807?
7 to the 5th power.
7 to the 5th power. 16,807.
You divided like first and then do it?
I divided the 2.
Yeah, that's great. 49 is 7 squared. Okay? So, 7 to the 5th power divided by 7 squared, that's going to be 7 to the 3rd power. Okay, you could have divided first, even on a 4-function calculator. Okay? So now I have 7 to the 12x power is equal to 7 to the 3rd power. Okay, you subtract if you want. Please make sure you put the negative 2x plus 5 in parentheses, because this is the most common mistake. All right, I've said it several times, but there will still be 5 people in this room tomorrow will not distribute the 3. Okay? This 3 in the front of the parentheses. So if the bases are the same, the exponents will be the same. So 12x is going to have to equal this quantity. So by a logical step, I'm going to set these equal to each other. Nothing's happening to the 7s. We just don't need them anymore. So distribute. So this is going to be negative 6x. Mr. Pizzuto.
He asked where Jackson was. I said the bathroom.
No, I care.
Well,
I need quiet, guys. Quiet. Negative 6x plus 15. All right? Don't just give me 5. It's 15. You have to distribute. The rest is easy. You know, we'll add 6x to both sides. That'll give me 18x is equal to 15. Divide both sides by 18. Okay, and yes, make sure that you reduce. All right, both of these are divisible by 3. No, 7s do not cancel out. We just use logic. We just use logic. They didn't go anywhere. X equals 5/6.
Wait, what did you do divided by 3?
All right, number 17. This one we need to get the variable term by itself before we can do our other shenanigans. So we need to add 100 to both sides, you know, in our standard algebra move. True. So we have negative 6 to the 5x minus 3 power. Try to do this ahead of me if you can. And this will be 216. I can't leave that negative out front like that. So I'm going to divide both sides by negative 1. Notice you can't multiply these two negatives and cancel them out right now. This negative is in parentheses. It's got an exponent on it. You can't touch it. So you divide instead. So this is going to give us negative 6. Stand by for 1 second. So 5x minus 3 is equal to negative 216. All right, now that we have the variable term by itself, it's time that we need like bases. Now, on the left, we have a negative 6 as a base. So let's see if we can write negative 216 with a base of negative 6. Is 216 on your chart?
Yes.
Where do you see it?
Third power.
Okay. Third power, 216, 6. 6 to the third power is 216. Of course, that means negative 6 to the third power will be negative 216. Okay, so I can rewrite negative 216 as negative 6 to the third power. And I'll just bring this down. Okay, Jordan, notice that my bases are the same. Okay, so we're not going to cancel out the negative 6's because that would be a division, and you can't divide away bases. So instead, we have to use pure logic. Okay, if the bases are the same, the only way that's going to happen is if the exponents are also the same. So by pure logic, we're going to go, okay, this must equal that. So 5x minus 3 must equal 3. And then we'll just use this new equation to solve for x. So add 3 to both sides. We'll get 5x is equal to 6. And then we'll divide by 5. And that's the answer.
Okay.
I'm reloaded.
I'm reloaded.
So x is equal to 6/5. Any questions about number 17? Okay. Let's move on to number 18. Oh, this one has the fraction in it.
Ain't got enough time.
No. What am I going to do? We talked about this yesterday.
Negative 1.
That's right. I'm going to use a negative 1 on it. Okay? 1/9. When I see 1/9, the first thing I think is 9 to the negative 1 power. Okay? So far I've got 2x minus 1. All right? I might have to change this 9. 9 is awfully big. Can't I write 9 as a smaller base and a power?
Yes. 3 squared.
Right, 9 is also 3 squared. So I'm going to look at this. If there's a way I can write 243 as 9 and a power, great. I'll use the 9. But I might have to write them both as 3's.
3 cubed.
Okay? So let's look at the chart before we go any further.
I mean 3 to the 5th.
Can I write, let's look at the 243. So I see 243 here as 3 to the 5th power. Is there a 243 in the 9 row? No. So we're going to have to do base 3. Okay? So 243, I'm going to write that as 3 to the what power was it again? 3 to the 5th power. So that's 3 to the 5th power. And I'll put x minus 7 in parentheses. So suddenly this 9 is not looking so good for me anymore. Instead, I'm going to have to do an extra step. Because I now see I need the 3. 9 is 3 squared. So that's 3 to the negative 2 power. And 3 to the 5, x minus 7. So this is where I'm going to set them equal to each other. 5x minus 35, don't forget to distribute, and negative 4x plus 2. All right, so the rest is easy. We need to get these x's together. So let's add 4x to both sides. So that's going to give us 9x minus 35 is equal to 2. Okay, and then let's add 35 to both sides. So that's going to give me 9x is equal to 37. Okay, and now I will divide both sides by 9. So x is equal to 37/9. So that is the answer to number 18. Number 19. We need to first get the variable factor by itself. So I am going to subtract 7 from both sides. So that is going to give me 10 to the x plus 6 power over 5 is equal to 200. Then I need to multiply both sides by 5. Okay, so that's going to give me 10 to the x plus 6 power. 200 times 5 is 1,000. All right, now at this point, we've gone as far as we can as far as just getting the x part of the equation by itself. Now we need to make these into like bases so we can set the exponents equal to each other. So clearly we have a base 10 happening over here. So we have 10 to the x plus 6 power. Now, see the 3 zeros? As a shortcut, we know that if we have a 1 followed by some zeros, that'll be 10 to the power. That's the number of zeros that you have. So 1,000 is 10 to the third power. If the bases are the same, then the exponents must be equal. So that means logic tells us that x plus 6 must equal the 3. So subtracting 6 from both sides gives us x equals -3. Okay, so that is the answer to number 19. Number 20, we need to go straight to the zone where we find like bases. Looking at the 36, and I'm thinking that's probably going to be 6 squared is the way to go. The 4x plus 3, we put that in parentheses. So 4x plus 3. Be sure to do this because we're going to have to remember to do the distributive property. Now, I'm hoping that 1,296 can be written as a base 6. Let's look at the table. All right, so there's our 6, and there's 1,296. So that is 6 to the 4th power. So 6 to the 4th power, that's 1,296. I still have the 2x minus 1, which again I will put in parentheses. Okay, now doing the distributive property, that means I have 6 to the 8x minus 4 power. All right, distributive property. And here I'll have 6 to the 8x plus 6 power. This is going to be very, very interesting. Anyway, if the bases are the same, then the exponents must be equal. But something strange happens. If I set these equal to each other, so I've got 8x minus 4 is equal to 8x plus 6. If I try to subtract 8x from both sides, like I normally would, both 8x's cancel out. All right, so I have no more x's. So I'm left with this statement. -4 is equal to 6. And that's just not true. -4 does not equal 6. So when the variables cancel out and you get a false statement, that's how you know that there is no solution. Now, please understand that if we had gotten a true statement, Okay, for example, imagine that instead I had gotten 6 equals 6, or negative 4 equals negative 4. Then we would have said infinitely many solutions. All right, so if all the variables cancel out and you get a true statement, that means there are infinitely many solutions. But if all the variables cancel out and you get a false statement, that means there is no solution. Number 21. Let us add 6 to both sides. All right, trying to get the x part by itself as much as possible. So we'll add 6 to both sides. So far, that gives us 1/2 times 1/8 to the x minus 1 power is equal to 256. All right, now I need to get rid of this 1/2. So I need to multiply both sides by 2. So these are going to cancel out. So that's going to give me 1/8 to the x minus 1 power is equal to this. All right, 512. Okay, now that's as far as I can go as far as getting the x part by itself. Now I have to somehow get these to be like bases. Let's start with the 512, see what our options are. Okay, I'm scanning. All right, I see 512 right here. That is 8 to the 3rd power. Interesting. Scanning, I don't think I see 512 anywhere else. So we're going to have to go with that. 8 to the 3rd power. All right, so that means I need this to be a base 8 over here. Well, that's fine. 1 over 8 is the same thing as 8 to the negative 1 power. So that will give us like bases. Since we already have this x minus 1 happening, I will just put that in parentheses. Of course, I will need to distribute. So this will give me 8 to the negative x plus 1 power. Now, if the bases are the same, the exponents must be equal. So this must equal this. So negative x plus 1 must equal 3. So I'm going to subtract 1 from both sides. So that'll give me negative x equals 2. So when I divide both sides by negative 1 to make x turn positive, that's going to give me x equals negative 2. So that is the answer to number 21. All right, with number 22, we have some square roots happening. So let's just be very careful. Let's start by trying to get the radical part by itself. So let's subtract 5 from both sides. So that'll give us 3 times the square root of x plus 6 is equal to 36. Next, I will deal with this 3 by dividing both sides of the equation by 3. That way these will cancel out. And so far, I will have the square root of x plus 6 equals 12. Now, to get rid of this radical, I need to square both sides of the equation. So I'm going to square this and I'm going to square that. Now the exponent and the radical cancel each other out. So on the left side, I'm just going to have x plus 6 all right, equals 144. All right, 12 times 12. So all that's left is to subtract 6 from both sides. So x equals 138. Pen is acting up. All right, but that is my answer to number 22. Now, anytime you're dealing with radicals, you definitely need to take your answer, plug it back in, and make sure it gives you a true statement. All right, this one is going to work out, but you need to always check your answers when you're dealing with radicals. Number 23. The move you want to make is to just get these radicals on opposite sides of the equation. So I am going to add this whole expression to both sides. Okay, I'm basically just trying to move this over. So that is going to give me the cube root of 3x plus 21 is equal to 2 times the cube root of 6. Now, normally we try to get rid of things like this before we go cubing both sides, but in this case we don't have a choice because no matter where we put this 2, there's going to be a radical there. So we'll just have to go ahead and very carefully cube both sides of the equation. So we'll cube this and cube this. You know, if you cube a cube root, the radical and the exponent cancel each other out. So that's going to give me 3x plus 21 equals. Now over here, yes, this cube and this radical will cancel each other out, so I'm going to have 6. But what about the 2? You're also cubing the 2, and 2 to the third power is 8. So a common mistake is to leave this as a 2. All right, but that would be wrong. We're cubing all of it. So we have 8 times 6. So this becomes 3x plus 21 is equal to 48. And the rest is obvious. We will subtract 21 from both sides. So that'll give us 3x is equal to 27. And then we divide both sides by 3. So that's going to give us x equals 9. All right, I think this is going to be the last problem. No, you know what? We only have 2 more problems. You know what? I'm just going to squeeze these in. Never mind. False alarm. We still got a couple of problems to go. Let's go ahead and get this variable part by itself. So let's add 5 to both sides. It's 5 plus 5. So far, that gives me 2 times the quantity 4x to the third power minus 13 to the 3/5 power is equal to 54. All right, then we're going to divide both sides by 2. All right, that'll cancel these out. So that's going to give us 4x to the third power minus 13 to the 3/5 power is equal to 27. Now, it's time to deal with this fractional power. I can get rid of that by doing the reciprocal power to both sides. That's the key. So 3/5, the reciprocal is 5 over 3. So I'm raising both sides of the equation to the 5 over 3 power. Now over here, these are going to cancel each other out. Okay, the 3's and the 5's. So that's why this is useful. So that's going to just leave me with 4x to the third power minus 13 equals. Now I have to do 27 to the 5/3 power. Now remember, in radical form, this might be easier to think about, where 5 is the power, 3 is the root. So focus on 3 being the root. That means we are dealing with the cube root of 27, and then 5 is the power. So that'll be all to the 5th power. Okay, the cube root of 27 is 3. So this becomes, maybe I'll just do it off to the side. So this becomes 3 to the 5th power. And I forget what that is off the top of my head. So 3 to the 5th power is 243. Okay, so that's 243. Anyway, I'll bring that back here. So all this is equal to 243. So I have 4x to the third power minus 13. So let's keep going, trying to get this x by itself. Okay, so I would need to add 13 to both sides. And I am running out of space. So this is going to be 4x to the third power equals, let's see, 256. Dividing both sides by 4. Okay. $64? All right. So that's going to give me x to the third power is equal to 64. And of course then, to uncube this, I need to take the cube root of both sides of the equation. So cube root, cube root. Okay, I didn't really leave myself enough space. So I'm going to move that over. All right, so this uncubes the x, and that just gives me x equals. And the cube root of 64 is 4. All right, the cube root of 64 is 4. And that is the answer. All right, now we were definitely dealing with radicals, so you should certainly go back and substitute this back into the original problem way back here, and make sure that this all boils down to 49. Okay? And you should do the same thing with number 23. Plug it back in, make sure it actually works. All right, last two problems. To determine if the sequence is geometric, we need to see if there's a common ratio. The way you find a common ratio, if there is one, is you take each term and divide by the previous term. For example, 12 divided by negative 2. Or negative 72 divided by 12. Or 432 divided by negative 72. Each term divided by the previous term. If this is geometric, we should get the same result every time. Of course, 12 divided by negative 2 is negative 6. What about negative 72 divided by 12? Well, you should know this by heart. That is also going to be negative 6. I'm betting this one is negative 6, but let's check. 432 divided by 72. Look at that, that's 6. So of course that means this would be negative 6. Now, when you get the same thing for every pair of numbers, that means it is geometric. All right, so yes, it is geometric. So maybe I'll just put geometric. All right. If it is, find the common ratio. All right, we found it. R is equal to -6. All right, that is the common ratio. Find the 8th term and the explicit formula. Well, let's find the explicit formula first. Now, here's the model for the explicit formula. All right, any term, an, is going to equal a1 times r to the n minus 1 power, where the a1, this is the first term. And the r is the common ratio. Okay, so our explicit formula then will be an. All right, a1 is the first term, that's -2. So we'll have -2 times r, and that's -6, to the n minus 1 power. So we'll just put n minus 1 power. So this is the explicit rule that they asked for. Now, the 8th term is given by A8. All right, A8 stands for the 8th term. And to find it, you can just plug in 8 as the power. So we'll have -2 times -6 to the 8 minus 1 power. Okay, so this is going to be -2 times -6 to the 7th power. All right, so it's just a matter of working out what this is. All right, this is tricky because 6 to the 7th power is off of our chart. All right, this chart only goes up to the 6th power, and some charts only go up to the 5th power. So we need to break this down into smaller pieces. Understand this though. When you have a negative number to a power, sometimes the negative stays and sort of comes out front, and sometimes it goes away. Is it going to stay or go away in this case? It's going to stay. When you have a negative power, like -6 to the 7th power, is just the same thing as -6 to the 7th power. The negative doesn't go anywhere. All right. By contrast, if I had -6 to the 8th power, that would be the same thing as just 6 to the 8th power. All right, with no negative at all. So the negative is going to stay. So that means what I have here is a negative times a negative, which is going to be a positive. So I can really sort of forget about the negatives at this point. Okay, so let's concentrate on figuring out, because, all right, the 8th term is going to be basically 2 times 6 to the 7th power. But this is too big. So let's take that 6 to the 7th power and work on it. Now I want to do the black screen. Okay. 6 to the 7th power. Let's just split it up as 2 smaller powers. For example, we could go 6 to the 4th power times 6 to the 3rd power. You don't have to split it up this way. You just need something smaller. You could have done this and done 6 to the 5th power times 6 squared. Okay, so you can really split it up however you want, as long as both things are on this chart. So I'm going to use the first one that I thought of. So 6 to the 4th power, okay, 6 to the 4th power, that's 1,296. And then 6 to the 3rd power, I believe, is 216. Yep. All right, so now I just multiply these two together. So I'm pretending like this is just a 4-function calculator because I will not be allowed to use my TI-30XS multiview on the test. So we've got, what do we have here? We have 1,296 times 216. So that is 279,936. Okay, so there you go. That is the 8th term. All right, number 26, last one. Let's check and see if this is a common ratio at all. Let's see if it's geometric at all. So, if it is, we should be able to divide each term by the previous term. Okay, this one gives us -3. So far, so good. Each term by the previous term. So 18 divided by -6. Again, -3. Last one. -54 divided by 18. And again, -3. Okay, so we have found our common ratio, R equals -3. Okay, now let's write our explicit rule. So the rule is going to be AN is equal to the first term, which is 2, times the common ratio, which is -3, to the n minus 1 power. So there is the explicit rule. Now we can use this to find the 8th term. So the 8th term is going to be A8. So that's going to be 2 times -3 to the 8 minus 1 power. In other words, 2 times -3 to the 7th power. So this negative is not going to go anywhere because it's the odd power. So let's see. So the 8th term is going to be, this negative is not going to go anywhere. So it's going to be -2 times whatever else. Well, I'm going to split up 3 to the 7th power as 3 to the 4th power times 3 to the 3rd power. Okay, I'm just splitting up the 7th power. I move the negative in the front, and 3 to the 7th is the same as 3 to the 4th times 3 to the 3rd. The reason why I did that, again, is because the chart doesn't go up to 7th power. So by doing this, I can actually finish the problem. So the 8th term will be -2 times, let's see, 3 to the 4th power, I believe, is 81. Let's check that out. 3 to the 4th power is 81. Now 3 to the 3rd power is 27. Okay. All right, I'm just going to have to squeeze this in over here. If I multiply these two together, 81 times 27. All right, I'm pretending like I have a 4-function calculator. So 81 times 27. That's 2,187. So I still have the -2. So it's -2 times 2,187. Okay? So now I'll do the -2 times 2,187. And that is -4,374. Okay, so this is the 8th term. And that is the end of this review. I hope it has been helpful for you, and I will see you on the next video.